So, hello, good evening, everyone. Am I audible to you all?
Yes, ma'am.
Yeah. So, I am Santra Krishnan. I will be the TA for this live sessions. So, I think like now we have 5 members or so. I think we can start in the meantime. If other people join, let them. So, I'll present my screen. So, is the screen visible to all of you?
Yes, ma'am.
Okay, so this will be the first session of live tutorial sessions, that is problem solving sessions on the course Fundamentals of Electronic Materials and Devices. You have enrolled for this course, and so far I think you have completed 3 weeks of these sessions. And as part of these live sessions, what we will be doing is that we will be solving questions that is related to the assignments that you have weekly. So I hope all of you have gone through the contents that have been uploaded so far, and in case you are planning to appear for the examination, please do register without delay. So, and speaking of me, I am Sandhara Krishnan P. I am a research scholar in the Department of Metallurgical and Materials Engineering in Soft Matter and Complex Fluids Lab at Indian Institute of Technology, Madras. And I am a PMRF candidate, and that is the reason why I am taking these live sessions. So these live sessions are in association with PMRF as well as NPTEL. So during this is the course details. So this course is being taken by Professor Parashuraman Swaminathan, who is a faculty in the Department of Metallurgical and Materials Engineering at IITM. And it is an 8-week course, out of which you have already completed 2 weeks, and third week is going on. Like the detail, like the sessions and the assignments have been uploaded, I believe. So based on this, we will be having a live tutorial session every week on Tuesday from 6 p.m. to 8 p.m. So in case your friends have also enrolled for this course, please do ask them to attend these live sessions. So it will be somewhat helpful for you in solving the assignment questions and at the same time when you are appearing for the final examinations. So these are the things. Usually what happens with an NPTEL course is that you will be continuously watching lectures only, right? You won't have a platform where you can actually ask doubts to the person, or there is no live interaction happening. So that is why NPTEL has come up with the live session idea where you can engage in a more interactive learning process. So we will be practicing assignments, and in case you have any doubts from the previous week assignments, we can discuss that as well. And if collectively people have a doubt on it, suppose one topic many people are having doubt, in that case we will be having topic discussion. But in case you want topic discussions, you will have to inform me early so that I can come prepared for that. Unless topic discussions are not required, we will be solving sample questions related to the weekly assignment. So that is the whole purpose of these live sessions. So I hope like till this much people might be wondering like what these live sessions actually mean. So in case you have any doubt regarding the live sessions, so if people can ask up right now. So does anybody have any other doubts regarding the registration for the exam or anything regarding the live session or any requests that you have? Please let me know right now. So in case you have start solving the assignments, I'm pretty sure, like I think you have already submitted 2 assignments. So in that questions also, in case you got any particular answer wrong or you were not able to find out the correct answer, please do note that and you can ask me that as well. I'm happy to, more than happy to solve those questions for you. Or any other doubts regarding this course or anything, if you have, you can ask right now or we can move on to the question answer sessions for today. Anybody, any doubts? Since we are only, yeah,
Yes,
please, yeah, sure.
uh, ma'am. Actually, in the second week, I thought one video is missed regarding this NC and NB equations derivations. There is only two videos. One is about the assignment, like problem solving, and directly there is next it is moved to the directly solving the intrinsic semiconductors. In between that ANC and V derivation video is missed, I think so. There is a no connectivity missing, ma'am. That I sense it, but I don't know exactly what it was happened.
Okay, fine, fine, fine. So surely I shall check it and I'll get back to you. So in case it is
Okay.
missing, it will be uploaded for sure. No worries. Yeah, thank
Okay.
you so much. Yeah.
Thank you.
So the issue is that directly after the problem solving, it goes to intrinsic semiconductor next set of
Semiconductor.
problems. Okay.
Mm-hmm. Yes,
There is
ma'am.
no discussion of NC and
So,
NB.
yes, ma'am.
Okay, fine, fine, fine. I'll clear that for sure. Anybody else? So I'm hoping that all of you are like watching the videos regularly instead of keeping it for the end where you have to watch all the videos continuously and appear the exams directly. So other than that, it would be better if you can go on a weekly basis. It will be somewhat organized and consistent, and you will get some kind of a benefit if you are regular in reading. Otherwise, it would be simply from the exam point of view. So I request that all of you go through the videos and assignments. And in case you get any doubts in any of the practice assignments or weekly assignments, please do let me know. And in case you're not able to ask any questions during the live session, there is a discussion forum in the NPTEL website, that is the portal, and you can post your questions over there. And at the end of the session, I will also be posting my mail ID on the screen. And in case you have any queries, you can send a personal mail to me as well. So these are few ways in which you can interact with me and make maximum use of this course. Anyway, you have enrolled for a course and you are spending a sufficient amount of time weekly on this thing. Sorry. So it is better that you utilize it to the maximum. So I think people don't have any other questions as of now. I think we can move on to today's session. And one more thing, during the sessions, I will be asking you to respond to the questions. And in case you have any particular doubt, or you are allowed to discuss with each other as well. So before answering, first you can try by yourself, or in case another person points out, gives a point, another person can add on to it. And finally, I want you guys to come to the answer instead of me directly explaining. Anyway, we are only a few members and we would like to be a highly interactive team. It's not like you're not supposed to ask any very simple doubts. You can ask any doubt, and doesn't matter whether you don't know also. So I'm also a student like you, so we can interact and follow. Like, you'll understand once we start the sessions, I hope. So I'll present my screen again and we can start today's question answer sessions. So is the screen visible to you?
Yes, ma'am.
Okay. So these are two very basic questions. So the first question is that the empirical observation made in 1965 that the number of transistors in an integrated circuit doubles every 24 months is called dash. Ryder's law, Moore's law, Haigh's law, and Gates' law.
Moore's law, ma'am.
Yeah. So does everybody else also agree with the same? Moore's law is the right answer. So does all the other people also agree to the same? And this recording as well as the PPTs will be shared to NPTEL and they will be uploading it in a drive, I think, where you will be given access to it. So don't worry about the uh, like taking notes as it is, or like trying to record or anything. You will be given access to these materials, so don't worry about that as well. So I hope Moore's law, the answer is clear to all of you. So the next question is, the nature of chemical bonding in silicon is covalent. What is the nature of hybridization of the material?
SP3, ma'am.
SP3.
Yeah. So I think all of you know the answer to it. These are actually very basic prerequisite questions. We will move on to like actual problem solving. But before that, I want to know whether you are familiar with the logical part of it. So SP3 is the right answer. So next is, which of the following are not n-type dopants for silicon? So more than one answer may be correct. And before telling me the answer, I want you to tell me the difference between n-type and p-type dopants.
N-type are giving extra electron. It is like donors type, and P-type it is a acceptor type, like taking the electron like that.
Okay, that is correct. So now if any other can tell me the answer to this question, which of the following are not n-type dopants? So in the exam, please note here it is already mentioned that more than one answer may be correct. So only if you
This
give
one,
all three answers or all four
this one.
answers, yeah, you will be given full marks. Otherwise, you will be given only partial marks. So what would be the possible answers here?
Bismuth and aluminum.
Okay, one more will be there.
Gallium also.
Yeah. So n-type means that the valency of silicon will be 4, right? Not n-type means that it should be a material or element whose valency is less than 4. So in that case, when we are comparing aluminium, bismuth and gallium, all three are correct answers. And only if you give all three answers, you will be getting full marks. Otherwise, you will be awarded only partial marks. So is it clear? If you see the periodic table and you see the group elements, you will be able to understand that aluminium, bismuth and gallium are materials whose valency is less than 4. So what happens when we dope silicon with those materials? What the number of electrons will be less. Hence holes will be created and these holes will be responsible for conductivity. And that is why these are not n-type dopants, or we can say they are p-type dopants. So is it clear? Is it clear to you?
Ma'am, can you please repeat last one? Oh,
So basically what happens is that silicon, we know, right? So during doping, what we do, we will add other elements to the silicon. So we have a possibility of adding other elements, and we have two possibility. One, we can add another element with more number of electrons than silicon, or we can add an element with less number of electrons than silicon. In case we are adding an element with more number of electrons than silicon, what will happen? In the final doped material, number of electrons will be increased. That is known as n-type doping. In case we are adding an element which has less number of electrons than silicon, then what happens? That is known as p-type doping. And in both the n-type materials, what happens? Electrons will be responsible for the increase in conductivity. In p-type materials, holes will be responsible for the increase in conductivity. Is that clear?
yes, ma'am.
Yeah. So in our case, what will be the answer then? Aluminium, bismuth, and gallium. Phosphorus, we know that it is an n-type dopant. So here it is as which of the following are not n-type dopants. That is why we have all these three answers are correct. Okay, I hope it's clear. So I think we can move on to the next question. That is, in an intrinsic semiconductor, the number of thermally generated electrons in conduction band is dash the number of holes generated in valence band.
Equal to.
Yeah. What about others? So are you also clear that it is equal to? Or do you want me to explain? Please feel free to ask. So please note that this is an intrinsic semiconductor, means that we are not adding any dopants. And thermally generated means that at a given temperature there will be a sufficient amount of electrons in the valence band due to the increase in energy because of temperature. So whenever an electron is generated, as a counterpart, a hole will also be generated in intrinsic semiconductor. So in intrinsic semiconductor, thermally generated electrons will be equal to the number of holes generated. That they both will be equal. But in extrinsic, what happens? Like in the case of question 3, we are adding external elements. So either holes or electrons can be more. So, but in intrinsic, they will be always equal to one another. This is because whenever an electron is excited to the conduction band, a hole will be left behind in the valence band. Is that clear?
Yes, ma'am.
What about the others? Is it clear?
Yes, ma'am.
Okay. So it will be equal to. So next is complete the following sentences. When n atomic orbitals in a metal overlap, they form n molecular orbitals and have n energy state, which can accommodate dash electrons.
2n electrons.
Yeah.
Electron, ma'am.
2n electrons is correct. Is it the same answer from everyone?
Yes, ma'am.
Like you have in the video, you might have seen that how atomic orbitals interact in case of silicon, right? So in case of silicon, sp3 hybridization occurs and n atomic orbitals combine, and two atomic orbitals are combining there, that is s and p. Then two sp3 will be formed, and finally each of those two can accommodate 2 electrons each, right? So that is what happens when n atomic orbitals in the metal overlap. They form n molecular orbitals, and each of them can accommodate 2n electrons. So that is correct. So next is the derivation of density of states. for an FEG metal involves calculating the number of available states per unit volume, but each state can accommodate more than one electron. Name the property of the electron that makes it possible.
Spin.
What about others?
Spin, ma'am.
Yeah. So
Spin,
derivative,
ma'am.
yeah, exactly. So what happens is that during the FEG metal, that is the free electron gas model, we will be drawing the available states, and there based on spin, we will be accommodating the electrons. So I hope that is also clear. So I think that most of you are clear with the conceptual part of these questions. So then we can move on to the solution part. So what is the density of states, that is G of E, of a free electron gas FEG metal at an energy of 3 electron volt? And I want you to answer in joule inverse meter power minus 3. So first one of you give me the equation for GE. So we need to have the equation for density of states.
8 pi root 2 multiplication of me by h square whole power 3 by 2 root e.
Okay, that is correct. And here E is given to us as 3 electron volt, right?
Yes, ma'am.
Yeah. So I want you to solve. Please start solving. You can take about 3 to 4 minutes for solving this question. So I will project the equation. So this is the equation that you have to use to get the density of states of a free electron gas metal at energy of 3 electron volt. So I want each of you to answer individually, and when I ask, I want you to give me the answer. Please to keep your answers ready. Using this equation, here this EF is given to us as 3 electron volt. And while substituting, please remember that you have to convert electron volt into joules. Then only we will get the answer in joule inverse meter power minus 3. Hence, please use this equation to substitute and tell me the answer. Like after 4 minutes, I will ask and I want you to give me the answer. And we can find out in case you go wrong anywhere. So either like the equation that she had mentioned before is 8 pi root 2 me by h square power 3 by 2. What happens is that in certain cases when you substitute the first equation on calculator, sometimes when we are doing h cube, it will converge to 0 because of the limitation of our calculator. So in that case, we'll have to use this equation. It's basically rearranging the first equation. So when you're substituting in your calculator, it would be better that you use this equation, because we know h value is 10 power minus 34, right? So when it becomes thrice, it becomes converging to 0. Once you have completed the calculation, please say that you have completed. Do not speak of the answer. Just tell me that you have completed.
B, ma'am.
Okay, are others also getting the same answer?
Yes, ma'am. B आ रहा है.
Okay. What about like other two or three people are also there, right? What about them? We have total four people in total. So two people got B. What about the other two people? Who all replied right now? Who gave the answers right now? Can you please mention your name?
Rashid, ma'am.
Okay, and one more person replied.
Saurav.
Okay, fine. So Harish and Saujanya, right? So you both are also getting the same answer?
Ma'am, a little bit confusion there. I mean, I'm getting math error while calculating.
Yeah, yeah, you can take a few more minutes to do. It's okay, it's fine. This is actually to help you in the solving part. So please take your time and others please bear and please do like try to find out where you went wrong so that during the examination we can minimize the error to the math. We can minimize it. Please try. So is this the substitution that everybody gave? Saujanya and Harish, please check like which substitution you had gone wrong. So
Same thing, ma'am. I'm trying, but something is like it's showing math error.
yeah, that is because usually what happens is that see, h is 6.626 into 10 power minus 34, right? So when you take square or cube of that, calculators won't be able to, it becomes something by zero, which gives us math error. So that is the reason why we usually go with the second equation. This would usually work, but if you try the first one, usually it will give math error. Yeah. So what about Harish?
Ma'am, I'm just solving this, ma'am. I
Okay,
get
fine.
math error.
Okay. Yeah, the other two people who got the answer, like you can discuss among yourselves also why somebody is getting math error and why the other person did not get math error. You can discuss that as well. Like anything you did in your calculator specifically to avoid that error or something. In case you did, you can discuss.
Ma'am, I use the above formula, which you mentioned above.
Okay, the
I using
second
the
one.
scientific calculator, which is installed on my.
Okay. Because during the examination we cannot afford a math error, right? So if you can identify what is going wrong right now, it will save you a lot of time during the examination, because in exam there will be many questions and you won't get this much time to solve one question.
Ma'am, one doubt is,
Yeah.
my question is कि when exam time I use my scientific calculator
Huh?
or not.
Exam time, I think you will be given an electronic calculator like the gate calculator one. I think you won't be allowed to use scientific calculator during the
Uh,
examination.
uh,
Yeah. And other thing you can do is that in so this value, right, during the examination you can see here that 8 pi root 2 me by x square by 3 by 2 is actually a constant, right? When you are studying for the examination, try to find the value of this constant. It becomes like 1.06 something, I remember. So in case you remember the constant's value, you can just multiply it by root of the energy value given. So that is the best thing you can do for examination. So this initial part, the whole thing is a constant, right? So if you calculate, I think, let me calculate. So can you just, somebody who have already completed, can you just calculate this value alone? That is 8 pi root 2 me by x square the whole power 3 by 2. That somebody can calculate and just let me know.
Yes, ma'am.
Yeah.
Ma'am, I got the B option,
Okay, fine.
7.3.
Yeah. So the constants value somebody got, the initial part. 8 by root 2 and me by its square the whole power 3 by 2's value.
Ma'am, that is like 2.8 into 10 to the power 53, that constant itself.
2.8 you are getting.
Yes, ma'am. 2.8 into 10 to the power 53.
Okay, is it the same for others also? Somebody joined right now, I think. Yeah. So in case you know the value, the constants value during the examination, what you can do is whatever energy value is given to you, you can directly put it as, you can convert the electron volt into joules and you can directly substitute. That will save you a lot of time. So in all such questions and equations, best that you find out the values of these constants. So I think all of you got 7. So this comes in numerator. 1 minute. This is a fault from my part. Sorry guys. So I think all of you got the second option, right? 7.3 into 10 power 46 joule inverse meter power minus 3. So I think now we can move on to the next question. So the resistance of a copper wire is 2 milliohms. If the length of the wire is 10 centimeter and diameter is 1 mm, what is the resistivity of copper? And you have to give your answer in nano ohm meter. So choose the nearest value. So this is a very basic, we know that everybody knows the equation for resistance, right?
R equal to rho
R
L
equal.
by.
Yeah, exactly. So, and in that case, I want you guys to substitute in this one. So, rho will be R into A by L. So, convert everything initially into meter or whatever unit is convenient to you. And finally, the answer you can convert into nano ohms. It's not that you have to initially substitute everything in nanometer. First, you do in meter and then give me the answer in what is the required form. So not only for this question, it is best for all questions like that. While calculating, compute in SI, and from SI you see the options and then convert.
Option B, ma'am, 15.7.
Okay, what about the other people and the person who just joined? Are you able to follow? I think Santhya, right?
B, ma'am.
Okay, what about the other 3 people? I
B.
want all of you to get the answer. Yeah. Now 2 more people are remaining. So this is the substitution that you have to do. 2 milliohms you have to convert 2 into 10 power minus 3. Then we are doing the area as pi r square. So r we are converting 10, so 1 mm is the dia. So 0.5 into 10 power minus 3 meter square will be the area. And finally length, it is given to you that it is 10 centimeter. The 10 centimeter also you are converting to meter. And this you will get in SI, and that S ohm meter you have to convert into nanometer, which means that there will be a factor of 10 power minus 9 in the answer that you get here. So is this the equation that everyone substituted?
Yes, ma'am.
Yeah. So you'll be
Yes,
getting
ma'am.
15.7 into 10 power minus 9, which means that it is basically nanometer. So I hope this is clear to all of you. It's a very simple question. So next is, what are the probabilities of an electron occupying an energy level of 0.01 electron volt above the EF? EF means the Fermi level at 300 Kelvin and 500 Kelvin. So you have an equation for finding the probability of an electron occupying a given energy level, right? So in that, at 2 temperatures and 1 energy value, you have to find out the answers. So can anybody give me first the equation that we have to use here? So density of states gives us the number of possible states, but it doesn't tell us whether the given state is occupied or not, right? Whether the given state is occupied or not will be given by one more equation that you have already studied. One is density of states and next is the probability of an electron occupying the given energy level. One is G of E and the other one was?
F of E, ma'am.
Yeah. So what was the equation for F of E? Any other person? Any other person, please give me the equation for F of E. Please feel free to answer. It's okay if it goes wrong also.
1 divided by 1 plus exponential of
Yeah. Exponential of?
1 plus exponential into E minus EF by KT.
Yeah.
KT is meant.
Yeah. So that is the equation. So this is the equation that you have to use. F is equal to 1 by 1 plus e power e minus ef by kt. Here it is given that the electron is occupying an energy level 0.01 electron volt above the EF, which means that between the EF and given energy level, the difference is 0.01, right? So what happens is that, suppose this is your EF, sorry for the handwriting, okay? And this is the given energy level E. It is, they are telling that our electron is occupying this place. So this is the energy level of our electron, and this energy level is at 0.01. So the difference between these two will be, suppose if this is 0, EF will be taken as 0 energy, right? So what will be the difference between these two? E minus,
0.01.
yeah, therefore E minus EF will be 0.01. So this equation may be got E minus EF, right? And K is a constant, we know Boltzmann's constant. And temperature you have to substitute in first case 300, second case 500. Therefore you'll get two values. So which of these two values will be there? Please do substitute and take your time, solve and tell that you have finished. I will ask you and then you let me know which is the option. So in case for people for whom it's not clear, our electron is occupying E. We are taking EF as 0. Then E minus EF will be 0.01 because here it is told that electron is occupying an energy level 0.01 above EF. This is our EF.
Ma'am, option C.
Yeah. Others also please find. And in the meantime, like you had told me the constant's value was something 2 point something power 56, right? Saujanya?
That is, yes, ma'am. That is without multiplying 8 by root 2, ma'am.
Okay.
If I multiplied that with 8 by root 2, that is also constant. So overall constant is it is like 9.94 into 10 to the power of 54.
Okay, I want you to recheck that actually because when I calculated, I got 1.0606 into 10 power 56.
10 power 56. Oh, okay, ma'am.
Yeah,
I
yeah.
got 10 power 54.
Yeah, can you
Something.
please, since you have already completed this question, can you please calculate that once more?
Okay, ma'am. I'm doing again.
Yeah, yeah, it's okay. Others, have you like got the answer as option C, right? E minus EF is known to us. K also is a constant. Temperature we have to substitute. And so is this the first case that you got? So value of K will be 1.38 into 10 power minus 23. And this electron volt also you have to convert it into joule because temperature we are substituting in Kelvin, right? So everything electron volt has to be converted into joules because our constant K we are taking in joules. This 1.38 into 10 power minus 23 we are taking based on joules. Therefore, electron volt also we are converting into joules. In case you are taking K in electron volt, you can use electron volt itself. That is your choice. Either you have to take both in joules or both in electron volt. That is the energy value and the K value. So the first case for 300 Kelvin will be like this. Is it clear? Is the first like temperature 300 Kelvin, is everybody getting the same answer as I am displaying?
Yes, ma'am.
What about the others? In case you have any doubts, please ask. Somebody just joined right now, I think. So others, are you getting the same answer like this one? And wherever you're finding the doubt, please let me know. I'll be clarifying. So this is electron volt. I'm converting the electron volt into joules because K value I have substituted in joules. In case you are substituting K in electron volt itself, no need to convert. Either both should be in joules or both should be in electron volt. That is the condition. So second case it will be like this 0.01, and in case sorry, here I have to substitute 500.
Ma'am, that constant value
Yeah.
I got 0.01 into 10 to the power of 55.
Oh,
It
yeah.
is like 10.1 into 10 to the power of 56.
Yeah, yeah. Okay, that is the, I think that is the correct part. Like, so the
Yes,
constant
ma'am.
value will be 1.0606 into 10 power 56.
Ma'am, repeat again.
1.0606 into 10 power 56.
Okay, one decimal point. Okay. Like I'm getting one, I mean, I got 10 to the power of 55 instead of 10 to the power of 56.
Okay.
Something. I will check again,
Yeah,
ma'am.
yeah. And this question have everybody completed?
Yes, ma'am.
Yeah. So what I was mentioning here is that here I have substituted K as 1.38 into 10 power minus 23, right? Suppose you want to substitute electron volt, you have to substitute 8.617 into 10 power minus 5. That also is possible. In that case, you don't need to convert 1.0.01 into joules. You can directly substitute in electron volt itself. Okay. So for everyone, is this question clear? And anywhere if you have doubt, please ask. I want all of you to be very clear with this question, because most probably you'll get such questions in examination and assignment. It will be there for sure. It's direct substitution. Only thing is you have to know which constant you have to substitute and which units you have to answer. That's all. So Saujanya got the answer. Then who replied right now?
Rashid, ma'am.
Okay, Harish, did you get the answer? Harish and Saurabh.
Me. Yes, ma'am.
Ma'am, I
Yes,
also
ma'am. I
got the
got
answer.
it.
Yeah, so all of you got the answer, right? Okay, that case we can move on to the next question. So in a metal at some temperature T, the possibility or the probability of finding an electron 0.2 eV above Fermi energy is 1%. The probability of finding an electron at the Fermi energy. What is the approximate value of T? Give your answer in Kelvin and use the FEG model. Like basically the same equation only we have to use, but a condition is given here, right? So what is given to us? Take a minute to read first and then I'll start. So here it is told that in a metal at some temperature T, probability of finding an electron 0.2 eV above Fermi level. Suppose this is our Fermi level EF, and somewhere here you have your energy E, and difference between these two is how much? 0.2 electron volt. So they are telling that probability of finding an electron here, that is in the energy E, is 1% the probability of finding an electron at Fermi level. So first everybody please find out what is the probability of finding an electron at Fermi level. So suppose you want to find the F of E at EF, what will be E minus EF? Suppose you want to find in this location, what will be E minus EF?
0.02.
No, you want to find out the probability at the Fermi energy. That is, you have to find out here. Like you are not going anywhere. Don't think only here. This energy only you think. There is nothing above. EF. Our electron is sitting here. Suppose you want to find out F of E here. Though then what will be E minus EF? There is nothing here above, right? So what will be E minus EF? That is our energy, that is our electron is sitting at the Fermi level itself. So E will be equal to EF, right? E means the energy where the electron is sitting. So in first case I am asking, our electron is sitting at the Fermi level itself. Then E minus EF will be, not clear?
No, ma'am.
Okay, I'll ask you once more. That is, see, the thing is that initially in this equation, whenever we are using this equation, that is, suppose this equation is there, right? This E minus EF, in this E minus EF, this E means that energy of our electron. That is, suppose we are thinking that our electron is moving from valence band to conduction band and it went to some energy. That is the energy of the electron. That is the present energy of the electron E in this equation. So we have equation for F of E and we have something as E minus EF. EF is the Fermi energy. E is the actual energy of the electron. So first I am asking you is that suppose our electron is sitting at EF itself. It is not going anywhere. It is located at Fermi level itself. Then in that case, what will be? It's E minus EF. That is, we have EF like this. This is our EF. Our electron is sitting here. It has not jumped to anywhere else. It is at EF itself. So in that case, what it will be? E minus EF will be?
0.
Yeah, exactly. So that is the case. So in case E minus EF is 0, then what will be F of E? In first case, what happens? E minus EF we have, and that E minus EF will be 0. So can you please calculate and tell me?
1.
E minus 1, no, 1 is not the answer.
Overall 1.
Sorry? So here E minus EF will be 0. That is because our electron has not jumped anywhere else. It is sitting at the Fermi level itself, and in our equation E means actual energy of our electron. So it becomes EF minus EF, right? So it becomes 0. That part is correct. Now you have to find out in F of E. Please substitute 1 by 1 plus E power 0 by kT. E power 0 by kT becomes E power 0. Therefore 1 by 1 plus 1 is equal to
1 by 2, ma'am.
yeah, 1 by 2 is 0.5. So that part you got. So this part you have already got here. Probability of finding an electron at Fermi level matlab you have got 0.5. Now they are asking, now the condition is that probability of finding an electron 0.2 eV above Fermi level is 1% of this value. So now second condition is that EF is here. Now the electron jumped to a higher energy level, and that higher energy level is 0.02 above. Sorry, 0.2, right? 0.2. This is a, now the electron is sitting here. It has jumped. The probability of the electron sitting here is 1% of this value. Is the condition clear now? Initially,
Yes, ma'am.
initially our electron was at Fermi level itself. Now it has jumped to a new energy state, that is 0.2 eV above the Fermi level, and that probability value is 1% of this answer. So 1% of 0.5 is equal to what it will become? E minus EF will become? So can somebody give me the statement what we have to write? 1% of 0.5 is equal to? Read the
0.5 by 100.
0.5 by 100 is equal to what I am asking? 0.5 by 100 is equal to, you have to substitute this equation again, right? Because they are telling probability of finding.
0.005.
No, no, I'm not asking that. The probability of finding an electron 0.2 eV above Fermi level. So this is one Fe equation, this is one Fe equation. So they are telling this Fe equation is equal to 1% of this Fe equation. This Fe equation you already solved and got 0.5. 1% of 0.5 is equal to,
Fermi energy location, ma'am, 0.05, and that EF.
yeah,
EF is 0.005.
no. So what have given that probability of finding electron 2 is 1% probability of finding. Can you write this statement in equation? That is what I am asking. So probability of finding an electron at Fermi energy we got as 0.5, right? That is clear to everyone, right? Probability, don't see the first part, read from here, wherever my cursor is, read from there. probability of finding an electron at the Fermi energy we got as 0.5. That is clear, right?
Yes, ma'am.
Okay. Now read the first part. Finding an electron at zero point 0.2 electron volt above Fermi energy is 1% of the value you got.
That is E value then, ma'am.
Yeah. So how you will write that in statement? 1% of 0.5 is equal to 1 by 1 plus e power. So this statement you
Is
can write
5
like
into
this.
10. Yes.
So is everybody clear how this statement came? This is the question actually. Probability of finding an electron at Fermi level we solved as 0.5. 1% of 0.5 is the probability of finding an electron 0.2 eV above Fermi level. 0.2 eV above Fermi level means we have this equation, right? 1 by 1 plus e power 0.2 by kT. That is equal to 1% of 0.5. Please read that sentence multiple times and see whether you can connect it to the equation. And in case you want to ask your doubt in Hindi, that is also fine. I'm able to understand and speak with a lot of mistakes. So I will try to be as like understandable to you as possible. So where you are getting the doubt, you please tell me. At Fermi level, the value is 0.5. That we got. 1% of 0.5 is equal to finding the probability of electron at 0.2 eV above Fermi level. 0.2 EV above Fermi level means F of E we can substitute like this. Um, where are you getting your doubts? Please let me know. Danish, Hassan Khan, Harish, Rashid, Saurabh, Saujanya. Like where you are getting your doubt, you please let me know. Somebody wrote something in the chat box, I think. Okay, no. So where you are getting your doubt, you please let me know. Then only we can move forward. Like first, we wanted to find out f of e at Fermi level. F of e at Fermi level we already wrote, right? F of e at Fermi level we got. Probability of finding an electron at Fermi level we got as 0.5. That is clear. Now 1% of this value, 1% of this entire value is the probability of finding an electron at zero point 0.2 above Fermi level. So again we have to make this equation and that equation will be equal to 1% of this value. So is it clear? Please respond. So in case you have the doubt, please ask. Hello?
Yes, ma'am,
Ma'am,
understood.
Yes, ma'am.
Yeah. Please tell,
got
please ask, please ask. Yeah. Is it clear or do you want me to explain again?
Yes, ma'am.
clear, ma'am.
Clear for everyone?
Clear, ma'am.
Okay. So then please solve and let me know. T value you have to find out. I want you guys to find out the temperature
Yes, ma'am.
value. Yeah.
Ma'am, 438 kelvins.
Yeah. So what about the others also? Please solve.
Ma'am, is it 440 Kelvin?
Yeah. Based on the 438 if you have got and you see the options. 440 is there in option. So 440 will be correct. What about the other people? Are they also getting 438? This question was there in your practice assignment, right? I think it was there in your practice assignments. And in case you have any doubts with your assignment questions also, you can ask. Am I audible to all?
Yes, ma'am.
Yeah. So I hope everybody got T value as 348.070 Kelvin, and it's approximately close to 440 Kelvin. So in the question you have 440, so that is why we take it as 440. So once more I'll tell that first we have to find the probability at Fermi level. At Fermi level we got it as 0.5. 1% of 0.5 is the probability of finding at 0.02. So we made the statement. So at Fermi level it is 0.5. 1% of 0.5 is the probability of finding the electron at 0.2 above the Fermi energy. Here we got 0.5 because in our this equation E is the present energy of the electron. If the electron is in the Fermi level itself, E will be equal to EF, right? So EF minus EF, it becomes 0. So is this question clear to everybody?
Yes, ma'am.
Yeah, what about the other guys? Is it clear to you? Hello? Others, is it clear to you? Other people, Harish, Rashid, and Danish Khan, is it clear? Harish, I think what you just said was not audible. We couldn't hear you.
Yes, ma'am.
Yeah. Some
Yes, ma'am.
problem there. Can you please repeat? Okay, which the whole question, or you want me to repeat only the last part? It's okay, I can repeat. We have plenty of.
Ma'am, only the last part, ma'am.
Okay, fine.
Don't
So basically what I told was that I was giving a recap of this whole question. See here they have told
The
me.
derivative part.
Sorry? Somebody told something in between.
Can you show the derivative part?
Yeah, this one, right? So basically what I was telling was that I was just giving a recap. So this,
How we take the 1.38?
sorry? 1.38. I am taking here
Where we
1.38.
take the
Yeah, this is the
1.30?
Yeah, this is because I'm substituting everything in meter square kilogram, that is joule terms. That is why this one also I'm converting to joules, denominator also I'm converting to joules. In case you are substituting your K value in electron volt, that is 6.718 something. In case you are using K in electron volt, you can use energy also in electron volt. Either use both in joules or use both in electron volt. That's all. That is why I'm taking 1.38 here. The choice is up to you. What I usually do is that I always substitute in SI and then convert if required. 1.38 into 10 power minus 23 I am taking here. In case you are using K in electron volt, it will be 8.617 into 10 power minus 5. That also you can use. But then you don't need to put 1.6 into 10 power minus 19. That is just for converting electron volt into joules.
Okay.
Yeah. So is it clear to all of you?
Yes, ma'am.
Okay. So next is, what is the dependence of density of states on energy in a three-dimensional solid? Increases linearly with energy, increases as the square root of energy, increases as the square of energy, independent of energy. DOS means density of states.
Option B, ma'am.
Yeah.
Increases with the square root of energy.
Yeah. What about the other people? Are you okay with the same answer? You have any other opinion? Other people, please, like, say if you are okay with the same answer or you are finding any other answer, and in case, like, what is that, like, what is wrong with the initial answer? A discussion way, like, you should be clear with the concept of density of states and why it is proportional to square root of energy. And like in the meantime, Saujanya, like, are you taking this course only in NPTEL, or like, are you doing it for credits in college?
Ma'am, I'm MTech student, so there is no possibility to transfer the credits.
Okay, so
I'm
you're
just
taking
doing the NPTEL
additional one.
course.
Okay, fine, fine. Is it relevant for your project?
Ah, yes, ma'am.
Okay, fine, fine, fine. Whom are you working with?
Ma'am, this will be next year. It will be decided in the February second week. The project guides and list.
Okay, fine, fine, fine. Yeah, I realized from your roll number that you're from an institute. That's why.
Yeah, yes, ma'am.
So, what is the dependence of density of states? So, in case you know the equation for density of states, you will be able to identify what is the answer. So, somebody other than who already answered, please tell me the equation for density of states. I'll ask, I'll call out your names. Okay, Harish, can you give me the equation for density of states? Or anybody else? Rashid, Rahul, Ashwati, Saurabh. Yeah, then Harish.
Ma'am, 8 pi root 2.
Huh?
8 pi root
8
under
pi
2 multiplied by e to the m e to the power 3 by 2 root under f by h cube.
Okay. So now you know the equation, right? So now it's Harish's turn. So we have the energy term in that, right? So seeing the energy term, which of the following will be the answer? So the equation is correct. This is the equation. So here we have the energy term, right? So then what will be the answer from the option? So density of states is what?
V is correct.
Yeah, exactly. Density of states increases as the square root of energy. So that's the answer for this. So next is the resistivity of two metals A and D are 16 and 56 nanometer respectively. Two resistors are fabricated from A and B respectively. The lengths are same. Diameter of A is twice the diameter of the resistor made from B. What is the ratio of their resistance? And you have to give your answer as RA by RB. So first, do not say the answer. Just try to read the question and understand what they actually want. Anyways, I don't know why I think it's creating some disturbance for the others. So yeah, now it's clarified. So we have already solved a question regarding the same. So it's basically a resistivity resistance equation only. So R is equal to rho into L by A. Here they have given you rho values for both, and resistivity is the rho value. Rho value is given to you. Also length is given to you. Diameter is also given to you. And the diameter is not a length. They are telling that it is the same. But diameter they are telling that resistor made from A is twice that is made from B. So you have to find out RA by RB. So can anybody tell me the equation that is used? Hello, am I audible?
R is equal to rho L by A.
Okay, so that is correct. So in that case, we can find out RA and RB, right? So this is clear. Now area we are taking is pi by 4 d square. Now you have to take ratio of RA by RB. Now,
8 reduce 7.
sorry,
8 by 7, ma'am.
which of the options? So RA by RB, when you calculate, what will be the final value you get? I was not clear. What were you telling? Like something 7 I heard. I'm not clear. Sorry. Can you repeat again? So you have RA, you have RB. Now you have to divide RA by RB. And a row is given to you, row A and row B is given to you as 16 and 56. Length is, they are telling that it is the same, so you can cancel them out. Diameter of resistor made from A is twice the diameter of resistance made from B. So the relationship between diameter you know. Based on that, you can cancel out diameters as well. So once you cancel all those things, RA by RB will give a constant value. What is the constant value?
0.28. 0.28, no?
No. Yeah, everybody please try and I'll ask you. RA by RB, how much you are getting?
0.07, ma'am.
Yeah, that's the answer. So please find out where you went wrong and I want all of you to get 0.07. Please try, and once all of you complete only, we'll move to the next question.
Yes, ma'am. 0.07.
Saujanya, are you getting 0.07?
No, no, something wrong. I'm trying.
Yeah, sure. Take your time, no issues. And is anybody from this group attending, like doing GATE this time? Giving GATE examination this time?
Yes, ma'am. It's me.
In which paper are you giving?
Huh?
Which paper you are giving?
Ma'am, next year.
Okay, fine. Like MT you will be appearing or XE you will be appearing? Which subject the GATE paper you are giving, I am asking.
Ma'am, electrical.
Electrical.
Ma'am,
Okay.
Yeah.
Yeah. So in case you are planning for next year's GATE examination also, in NPTEL itself you have video solutions and live session for GATE also. So you can attend that as well. NPTEL also has live sessions for GATE. Like many video solutions are uploaded and there are few lectures available in YouTube as well. So please check for your respective subject and please try to see them when possible. Once you have revised, you can use your free time in viewing those answers. In case you have any doubt also, you can approach the respective TAs. Yeah. So did everybody get 0.07?
Yes,
yes,
ma'am. I
ma'am.
was about the same.
Yeah. So you will get something like this. 0.0714 will be the final answer that you are getting. Yeah, is it clear to all of you? So next is the process of increasing carrier concentration by adding impurities to an intrinsic semiconductor is called. No, I'll call out names. That person has to answer.
Doping.
Yeah, okay, doping. No issues.
Doping.
Yeah,
Doping.
yeah. So next is at absolute zero temperature, the conduction band of a semiconductor is.
Completely filled. Conduction band and completely empty.
Yeah. So what about the others? Do you also have the same opinion? At absolute zero means there is no thermal excitation going on. Everyone is in their, like all the electrons are in their respective positions itself. They have not started vibrating or moving to higher energy state. That is what is meant by absolute zero temperature. So then conduction band of the semiconductor will be empty, right? No excitation is happening.
Yes, ma'am.
Yes, ma'am.
That is why we are telling that at absolute zero temperature, conduction band is completely empty. So which of the following is an example of a 3-5 semiconductor? 3-5 matlab it will be an element from third group and fifth group. By combining two of them, you got a semiconductor. So which of the following is an example of a 3-5 semiconductor? Sorry, I didn't hear you. Option B. Yeah,
Option B.
yeah. So is it?
D, ma'am.
Yeah, B is the right answer. So now that you have completed so many questions, and unpresent, and in case you have any doubt with your previous assignment, you can ask now. Like assignment questions, if you have now, you can read the questions, and if you have any doubts, we can discuss that questions. Like your submission assignment, suppose you have to submit your weekly assignments, right? So when is the last date for the assignments?
Tomorrow, ma'am.
So in that case, you might have already solved, or like you got all the answers, or in case you have any doubt, please check and let me know right now. We can solve that as well. You have assignments 1 and 2, right? Due by now. Which assignment is due right now? Tomorrow?
Both, ma'am.
1 and
Both of them.
1 and 2 you have to submit tomorrow.
Yes, ma'am.
Okay, fine, fine. In that case,
Yes, ma'am.
please go through the questions right now and let me know whether you have any doubt with those questions. Like you don't need to spend excess time other than this. So in the session itself, we can solve that as well.
Ma'am, I have one doubt.
Yeah, please tell me.
The question is that about molecular orbital filling in order of increasing energy. So, which principle doesn't govern how to fill in the I mean
Wh-
molecular orbitals takes place?
Which principle doesn't govern? Which is the question? Like question number, can you tell me?
That is 13, ma'am. In the I think in assignment one itself.
Okay, molecular orbitals are filled in the order of increasing energy. Which of these principles governs
Yes,
how
ma'am.
filling of the molecular orbitals takes place?
I'm confused between the Ohm's law and this Medling energy ordering rule, ma'am. So that I won't get it. What is the difference between these
No,
two?
Hunt's rule is basically for spin, right? Basically, first you have to fill. They are asking molecular orbitals, how do you fill? First, low energy has to be filled, and then only high energy has to be filled. Right.
Yes, ma'am.
So Hunt's rule, what does it say? Hunt's rule means that with respect to electron spin, first suppose you have some 5 to 6 boxes, first everyone should be singly occupied and then they should be doubly occupied. Right.
Yes, ma'am.
So,
But in the molecular orbitals, it should be occupied at the same time. Once it is completely filled, then only it go for the next state, right,
yeah,
ma'am?
next state means higher energy level. That is what they are asking. They are asking with
Mm.
respect to energy level only. So that is one different rule.
So, so Hansel rule is not governing equation then, ma'am.
Yes. So then what will be the answer?
Here the question is which is does not govern the filling molecular
Yeah.
orbitals. So, except that the fourth option, remaining three options will be applicable.
No, I don't think so. Like you have to see Heisenberg's and like all four statements you have to be clear. Hunt's rule means that single filling. Madelung energy we know, like when we read density of states, we know ordering mode. Pauli's exclusion and Heisenberg uncertainty. Pauli's exclusion principle, what was the statement?
That is also a single filling, ma'am. Once the all
Okay, the question is
complete
molecular
all
orbitals.
fill, then only double filling will
Okay,
happen.
so which of
So
the following?
all these principles are same. I'm
Okay, you are having whether doubt whether more than one is correct or not. So,
yes, ma'am.
okay, which of these principles? So, can you read the question once more?
Molecular orbitals are filled in the order of increasing energy.
Okay,
Which of these principles does not govern how the filling of molecular arbitrage takes place.
Okay. So let me see the options one for does not govern they are asking.
Yes, ma'am.
So Paulis is there. So in that case, you will have to go with, so statements you will have to check. I don't know if there is more than one answer correct to this. I'm not supposed to give you the right answer. I'm just, that is why I'm thinking how to answer. Like they have asked us specifically not to give correct answers. I can just discuss. So Heisenberg's uncertainty
Yes, ma'am.
principle, can you give the meaning of Heisenberg's
Here,
uncertainty? Hello?
ma'am, here I'm getting confused with that each principle. Yes, ma'am. Each principle is looking the same. That's what my confusion. Every
Okay.
principle abbreviation is little bit similar.
Okay. So I think,
I'm not getting the difference between this
yeah.
Pauli version and Horn's principle like that.
Pauli's exclusion principle actually is that a single atom, no two electrons will have identical set of quantum number, right?
Yes, ma'am.
So Hund's rule is that it should be singly occupied before doubly occupied.
Yes, ma'am.
Heisenberg uncertainty principle we are already using while we are calculating density of states, right?
Yes, ma'am.
So you are finding that you are feeling that all of them are used.
Oh, no, ma'am. The first Heisenberg and Hunds.
Okay. Like once you submit, I can discuss the correct answer, but now I'll have to provoke you to think more. You already know the answer, I'm getting that feeling, but you'll have to refine your thought. You're almost clear about it. Just think once more, and once you have submitted, I can discuss. Before that, I'm not supposed to submit, that's why.
Okay, ma'am. I got a little bit clarity.
Okay. Police is there, Madeline energy ordering rule is there. Others, any question? What about assignment 2? Any others? Yeah, and Saujanya, please do remind me to discuss that question next week, okay? For the assignment
Okay,
part, it's
ma'am.
okay, but for the examination point of view, we can discuss that. So next week, I'll be discussing that question. So please do remind me, okay? Yeah, so anybody else, any other question in case you have any
Okay, ma'am.
doubts? Anybody else? Meeting.
Ma'am,
Hello? Yeah.
ma'am, I have not uploaded the assignment yet.
Okay, fine.
I will be solving the assignment today or tomorrow.
Okay, fine, fine.
So if I got the doubt where I can ask the question, ma'am.
Okay, fine, fine. So in that case, I think today's session we can wind up. So I want all of you to go through the assignment as soon as possible. And in case you get any doubt, please do email me. Yeah,
Ma'am, in
Yes, ma'am.
yeah.
second week video lectures,
Uh,
I I got only two videos,
okay,
and third one is the summary video.
okay.
All videos are not present.
Okay, like Saujanya was also telling the same thing, right? There is some discontinuity and the NCNV video is missing.
Yes, ma'am.
Okay, fine, fine. So I'll ask the person uploading to check whether it is in the correct order. In case something is missing, it will be uploaded to you. Yeah, so in case
Yes,
you
ma'am.
have
Okay.
any additional doubts while solving, please do email me at this mail address, santra.pmrf@gmail.com. So people who are planning to solve today, please don't post all questions. To some extent, I can help since there is very little time. So otherwise, in next class, we can discuss those answers. And provided you send me this doubts at a reasonable time. I will be trying to solve them. Tomorrow, what time is the deadline? Hello, like what time do you have to submit, or is it like any time before 12 a.m. is fine? Hello?
Ma'am, it is like night, ma'am, 23:59
12
hours.
o'clock, ma'am. Night
Yes,
12
ma'am.
o'clock.
12 a.m.
Yeah, so please try to solve, and in the meantime, if you get any doubts, email me at sandra.pmrf@gmail.com. And any other feedbacks or suggestions, like I should go slower, faster, anything, in case you can tell me, and we'll modify accordingly. So that's all for today. Thank you so much for your time.
Ma'am,
Yeah, please tell me.
excuse me, ma'am.
Yeah, sure. Please tell me. Yeah. Yes,
Ma'am, is
Harish.
it possible to change the session
Sorry.
day? Can we do it in Sunday?
Sun.
Can we do it in Sunday, ma'am?
No, the thing is that initially forms were given to us, then the slot is fixed because different people are taking different subjects, right? So now once it is fixed, it would be difficult to change the slot. But in case you are missing
Okay,
anything on
ma'am.
Tuesday, I think I'll be able to upload videos on YouTube and you can go through that.
Okay.
Yeah. So that is one
Okay,
possibility.
ma'am.
Thank you so much. So thank you everyone. Yeah, you can leave right now.
Thanks, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Bye bye.